Hi, my name is Mathias Brossard, and I'm a principal security architect at Architecture and Technology Group at ARM, and I'm based in Austin. I'm presenting here some work from Paul Howard, who couldn't be with us. My main work currently is working on the Confidential Compute Consortium project called Veracruz, which is about secure multi-party computation using trusted execution environments. And but I'm here to talk about another topic. So I usually have to explain what Attestation is, but here I'm basically preaching to the choir. But even so, unless you missed all of the keynotes this morning, I don't know if I can convince you even more than that Attestation is important. But so if you look at all of the CCC projects, they all include some form of attestation because you need to. And they also try to target different underlying technologies. So they face some of the issues that when they want to target multiple technologies, that they have to tackle the problem of doing the attestation on the host, and they need to tackle the fragmentation of the data formats, what the kind of contracts they want the attestation to honor, and the fragmentation of the verification APIs and or services. So at least for the first one, we think we have a solution, or we have a solution to try want to offer. So one of the projects that I've been working at since 2019 is called Parsec, and it really started outside of the realm of computational computing because it was mainly for giving access to the platform security features, and then mostly focused on signature and encryption, and leveraging as much as possible what the security features of the platform. So in that sense, it started also mostly on the edge side, IoT side of ARM, leveraging either the ARM PSA or the TPM solutions. But lately, we've been trying to add to the scope of Parsec the attestation. And so, for instance, as we already support TPM, we could just add support for TPM quotes. To kind of demonstrate the value of the Parsec, we've integrated that into a use case. So as part of the IETF TLS work group, there's an effort to extend the TLS specification to accept EAT tokens. So if part of the RAT work group, there's an effort to standardize the formats for attestation. And we want to be able to support those attestation tokens to add them to be as a replacement for X509 certificates. And the idea to kind of tie into the native attestation protocols and bind them into the TLS sessions. So we've been able to do that with a PSA attestation, which is kind of IoT microcontroller attestation formats, and the TPM. And now we've been doing the work to do the attestation with ARM CCA. You see this is kind of a whole flow that includes the deployment and the distribution of attestation secrets. So we also have the kind of explanation of the proof of concept of how that porting to ARM CCA happened. And the kind of proof of concept creates three different kind of entities as Docker containers, where the first one is the tester that's running a simulation or emulation of the full CCA system, the relying party, and the verifier. And the flow goes as following: is that once the verifier is provisioned with the different key material to verify the tokens, the attester would start a TLS 1.3 CLS session to the relying party, and I would include the native attestation token. That native attestation token would be verified by the verifier, and the results would be is it an acceptable policy or acceptable token, after which, if it's successful, the attester can use its private key to the authentication. And the importance of this is that once that attestation has been performed, or the TLS session has been performed, the relying party knows that the connection is to the enclave, the CCA enclave, knows what code is running on the other side, knows what platform it's running on. So it's a really powerful tool in the toolbox of using enclaves. So some use case, there's been some proposals to support VTPMs as a solution to bridge the native attestation and to a common model. So as mentioned, Parsec already supports TPM integration, so we can really simplify the task of integrating into existing application. So yeah, so what can you do? So Parsec is developed using Rust, and we invite you to improve and add other backends if you want to support other kind of either for security and signature encryption, access to secrets, or for, in this case, in the realm of confidential computing, any kind of attestation mechanism you want to add to it. But if you're creating applications that want to be leveraged at attestation, then we invite you to consume the Parsec APIs, either natively in Rust or with the different bindings that exist, Go, Java, C, C++, or if you're lacking one of them, you can contribute a new bindings to a new version. So here are the links of the different elements. So the Parsec software itself, the attested TLS demonstration, and Verizon, which is the verifier, open source verifier, part also of the CCC project. Do you have any questions?
Or 1 to 2 questions, if. Okay, otherwise, let's thank our speaker.